Hey everyone. So I wanted to do this video to kind of give you a quick reteach on the topic of torque and equilibrium. I know this is something we have already done in class, but I wanted to go over it quickly and kind of cover the topics that are going to be most helpful when it comes to retaking the assessment, which you'll be doing soon. So let's kind of go over just the basics, and we'll also discuss kind of what is torque, what is equilibrium, so we have a kind of a greater understanding of what is happening. So let's start with just this idea of what is torque. What is this word that I'm using here? So torque is what happens when I use a force to rotate something. So this is what we're going to call a rotational force. And what I mean by that is, let's say that I have a pivot with a lever attached to it. And I take a force, and I'm just going to abbreviate my force F, and I'm going to apply this to the end of the pivot. Here's my pivot point. Okay. Now pivots can't move. That's why we call them pivots. But this lever, instead of sliding down, is instead going to follow a rotating path this way. And so what we get is we get this rotational motion that we're referring to as torque. So torque is the force that is causing something to rotate. Now, that doesn't seem like a very complicated idea, and it's not, because we can calculate torque really easily. Our equation for torque, and I'm going to represent torque with just a capital T, is that all we have to do to calculate the amount of torque being applied to something is we're going to take the amount of force that we used, and we're going to multiply that times the distance away from that pivot point. And so what that looks like is, let's say for my example that I have 30 newtons of force. And I am going to apply that, and here's my pivot point. And if I measured this distance, let's say this distance was 2 meters of distance. And so if I wanted to calculate the torque that I'm applying to my example pivot, I would take my 30 newtons of torque, and I'm going to multiply that times my 2 meters of distance away from the pivot. And I'm going to find out that I have 60, and our unit here is Newton meters. I have 60 Newton meters of torque that I am applying to this lever. So I want you to think about a standard lever. This could be something like an actual lever, or you could think of something like a wrench or a door or anything else where one side of an object is fixed. If I take this force and instead of moving it at 2 meters away, let's say that I change my force and instead I move it now at 1 meter away, and I still use the same amount of force, 30 newtons. So here's my 30 newton force. It is at 1 meter away from the pivot. That's an M, 1 meter. Okay, I've cut my distance in half. I'm still trying just as hard, but now instead of having 30 times 2 in my equation, this is no longer relevant because now I have 30 times 1 meter, and I only have 30 Newton meters of torque. And so just by changing the distance of where I'm applying my force, I've dramatically changed. I've cut my amount of torque in half. And so this is why if you're using a lever or a hammer or a door, where you apply that force, where you push or pull from, makes a really big difference in how you experience that torque. And so this is kind of the beginning of understanding that it's not just how much force you use, it's where that force is applied. All right, so that's our idea of torque. So torque is a force that makes things rotate around a pivot, and the things that we need to know are the force that we're using and the distance away from the pivot. Now this up here is the only equation that you are going to need for all of your level 1 problems. So if you are just trying to get that level 1, you need to be able to take the force and the distance, and you are going to multiply those things together. Okay, now an example of a level 2 problem for this particular topic is, let's say that I tell you that you have a torque of, I don't know, let's go with 180 Newton meters. And I'm going to apply that at a distance of 3 meters away from the pivot. So in this case, here is my pivot point. I've got a nice lever here. I'm going to take a rotating force of 180 meters, and I'm applying that again. This is a distance of 3 meters away from the pivot. So if I was to give you something like this is a level 2 example. Again, I'm going to use that exact same equation. So I still have torque is equal to force times distance. But in this case, my torque is one of the things I've been given. There's 180. I don't know the force. That's the thing that I am trying to solve for. So I don't know F. That's a question we don't have. Okay, but I do know that my distance is 3 meters. And so if I find myself in a position like this and I need to solve for something that I don't know on that side of the equation, what I'm going to do in this case is I can divide both sides by 3. So I'm going to divide both sides by 3 meters. And on this side of the equal sign, this will cancel out. And on this side, I'm going to have 180 divided by 3, which if you grab a calculator or you do it in your head is just 60. And so I know that I have 60 newtons of force is going to be needed to create 180 newton meters of torque at a 3 meter distance away from the pivot. So that's a level 2 problem. In level 2, I'm going to give you the torque and either the distance or I'm going to give you the force, and you have to be able to know that you have to divide those and you have to know which one goes on the top of the fraction, which one goes on the bottom. So level 1 and level 2 both use the exact same equation. So in fact, I'm going to go ahead and highlight this in red for you guys. This equation right here will get you through the level 1 and level 2 problems. So it's not terribly complicated, but you do have to be able to do a little bit of math with it. Now, when we introduced level 3 problems, we also introduced the level or the idea of equilibrium. And what equilibrium is that equilibrium means balance. And so let's say that I have a beam with a point in the middle that's balanced. Think of this like a seesaw. If I put a box on one side, it's going to try to get the beam to swing this way because this is my pivot point. Again, so here is my pivot point right here in the middle. So if I put a box on just one side, it's going to make the left side go down and it's going to rotate around that pivot point. But if I put another box over here, it's going to have the exact opposite effect, and it's going to swing this way. And when we are in a condition of equilibrium, that means that both of those torques are going to be balanced. So if I was to take torque is equal to force times distance over here, and torque is equal to force times distance over here, what I would find is that these things are going to be equal if it's in equilibrium. So that's where we get that word equilibrium. It means that they're equal, they are balanced. And so in level 3 problems, I'm asking you to be able to balance an object. So if I give you one side of a balance beam, you should be able to, and some information about the other side, you should be able to try to solve for this. So let's go ahead and scope out a practice problem then. So here is a balance beam. I'll go ahead and set one up just like my example. And on one side, I'm going to have an object with a mass of 4. It's going to apply 4 newtons of force downwards. And on the other side, I'm going to have an object with, let's go with 2. Here's 2 newtons of force on this one. So if this object is 2 meters away from the pivot point, how far does this object have to be in order for it to be balanced? Now, we can solve this using our torque equation. But in this case, I'm not just going to write it down once, I'm going to write it down twice because we have 2 objects. So I'm going to say I know that torque is equal to force times distance. Again, that was our equation up here. Torque is equal to force times distance. This is still important because now I'm going to say that the force times the distance on the left side of my pivot point is going to be equal to the force times the distance on the right side of my pivot point. Again, they are in equilibrium. I need these things to be equal. And so I have a block that is applying 4 newtons of force at a distance of 2 meters away from my pivot point, and I'm going to set that equal to a force of 2 newtons, again, that's the power or the mass of the block, times some distance that I don't know. So here's my question mark. If you're doing this in math, you could think of about this one as being a variable, like x, and that's the thing I'm solving for. So let's go ahead and solve for that variable. 4 times 2 is 8. So 8 is going to be equal to 2x. And in order for me to get x by itself, I will divide both sides by 2. On this side it cancels. 8 divided by 2 is going to give me 4. And so I know that the distance that my object is away is going to be 4 meters. So that's the distance that my 2 Newton block would have to be placed in order for this pivot to be balanced. And so that's equilibrium. Again, not very complicated, but we're gradually getting increasingly difficult with how we can handle this mathematically. All right, now ultimately, you might take a stab at a level 4 problem. So here's level 4. Level 4 doesn't change any of the ideas. In fact, we're going to keep the ideas. Level 4 just asks us to apply to these to a more complicated situation. So again, I'm going to create a balance beam, and this time I'm going to make a really big one because I'm going to put one huge object over here. This is going to be, I don't know, let's go with 16 newtons. It's a big object. And that 16 Newton object is going to be 8 meters away from my pivot point. Now over here, I'm going to balance this with 2 different blocks. One block here and one block here. Okay, block number 1, I'm going to give you some information about. It is 8 meters, or it's 8 newtons worth of force, and I'm going to put that at about, let's call this 4 meters away from the pivot. Now, I have another 8 newtons right here. What does the distance from the pivot point all the way out to this 8 Newton block have to be in order for it to be balanced? That is going to be our variable. That is x. So I don't have 2 objects now. I have 3. So let's go ahead and see if we can solve this one. And again, we're going to solve it with the exact same way. I know that torque, again, is equal to force times distance. And I know that in order for all things to be equal, I know that the torques on the one side of my pivot and the torques on my other side of my pivot have to be equal. So all the things have to be equal. That's equilibrium. So let's go ahead and start plugging some numbers in. I know that this is going to be force times distance, and I'm going to set that equal to force times distance plus force times distance. I have 3 objects. I have 3 torques. We're going to do force times distance 3 times. So it gets a little bit longer, but it's still something that we can do. So here's 16 times 8. We know those numbers. Here is 8 times 4 plus 8 times x. We'll call that x. I'm going to grab my calculator because there's no reason to have to do this with in your head. So 16 times 8. I'm going to get 128 on this side. 8 times 4 is 32 plus 8x. So our math is going to get a little bit more complicated. The first thing I need to do, and this is a level 4 problem, so I'd expect it to be a little more complicated, is I need to get the thing with my variable isolated. That means I need to get it on its own. And so I'm going to subtract 32 from both sides because I need to get 8x by itself. 32 minus 32 is 0. So that's just going to completely cancel out. And 128 minus 32 is going to give me 96. So now I have 96 is equal to 8 times x. And now because I need to get my variable all on its own, I'm going to divide both sides by 8. So that will cancel on this side. And what I'm going to get is that x is equal to 12. And so if I go back, and that's 12 meters. So if I go back up to my original diagram, that one, this block right here is only 4 meters away, 4 meters away. X right here, this is going to be a block that is 12 meters away. And if I put those two blocks there, it will perfectly balance my big block on the other side. So that is kind of your quick version of torque and equilibrium. And that's how to solve your level 1 through your level 4 problems. I hope you found this to be helpful, and I hope that with a little bit of practice, you'll be able to do all of these problems on the retake.